Today we're going to review properties of exponents. You've done this in Algebra 1, so it may start to look familiar. The first one we're going to talk about is when you are multiplying your bases. So what's going on here is I have a base a raised to some power n, and that same base a raised to a different power n. So note that the numbers are the same, it's the exponents that are different. So when you have the base that's the same and the exponents that are different, you can add the exponents. And let me show you how that works. So if I have x to the second times x to the sixth, you know x to the second really means x times x. This exponent is telling you how many times you have that base multiplied by itself. And x to the sixth really means x 6 times itself. So if we look at that, we have how many x's? 1, 2, 3, 4, 5, 6, 7, 8. So we have x to the 8th. And if we use this property, we have x to the 2 plus 6, which is also x to the 8th. So you can write it out like this and count them, or you can just use this property. So it just saves you a little bit of time. So this is when you have the same base being multiplied, so the bases are being multiplied together. You need to add the exponents. Just a little, this is what we're doing in words. Okay, the next one, the next property says if I have a base divided by that same base and they have different exponents, this time I subtract the exponents. So again, let's see that in action. X to the 7th divided by x to the 3rd, well, you would make that x to the 7 minus 3, so x to the 4th, so let's see how that happens. I would have x 7 times being multiplied in the numerator and x 3 times in the denominator, and when you're dividing and you have a factor that's the same in the numerator and denominator, you can cancel it. So I can cancel these x's one at a time. And then what happens is I have just 4 x's left. So this is when you have the same base being divided, you subtract the exponents. Alright, so that being said, sometimes you are going to have an exponent in the numerator and the denominator, like this one, and obviously they're going to be different. And does the order you subtract make a difference? So let's talk about that. The order you subtract makes a difference. So if I have x squared divided by x to the 10th, okay, so if I just follow my rule, then I would get a negative number, right? Because 2 minus 10 would be a negative number. But if I start with the big one, 10, and subtract 2, so I started with, where's the 10? Numerator or denominator? It's in the denominator. If I started with the denominator, then the answer, when I do 10 minus 2 and get 8, the answer goes in the denominator. So it would be 1 divided by x to the 8th. But if I do 2 minus 10, so here I started with the numerator, the answer goes in the numerator. So it would be x to the negative 8th. But as we'll see in just a second, you can't have negative exponents, so well, we'll talk about that in just a second. Okay. So negative exponents. Negative exponents are not allowed in any final answer, so anytime you have negative exponents, you have to take care of them. And how you take care of them is you move the base up or down across the fraction bar, and you change the sign of the power. Okay, so I have x to the negative m. That is negative. I can't have it. This is over 1, so I'm going to move this whole thing down. So now it will be 1 divided by x, but now that I've moved it across, that changes my sign to a positive. So if I started with it in the negative, if I started with the negative in the denominator, then it moves up. So I have a to the positive n. Now, this does get a little tricky when you have a negative base. If I have negative 3 raised to the negative 8, let's put this over a. When I do this, this exponent is negative, so I do, let's add negative 2 to the 4th. Okay, so which one of these is going to move? Negative 3 to the negative 8 or negative 2 to the 4th? Only one of them does. Only the one with the negative exponent moves, not the one with the negative sign out front. So this whole thing is going to move down. So I'm going to have 1 over, because if you move that whole thing, you have to leave a 1. And these two don't matter, so I'm going to have negative 2 to the 4th and negative 3 to the 8th, and I still have my a down here. So just because it has a negative sign outside doesn't mean it's going to move. It's only when that negative is in the exponent here. Okay, so up here we can't have negative exponents, so this actually is going to become 1 divided by x to the 8th. So then you can see that these two are the same. So back to subtraction, does the order make a difference? Yes, it makes a difference where you put it originally, but if you have a negative exponent, then you need to move it to get your final answer. Okay, so next we are going to do power to a power. Let me find the top of my paper. So if I have my base a raised to the power m, and then that all raised to the n, I have a to the m times n power. So notice there's only one base this time and 2 powers. When that happens, we multiply. So this, like x to the 5th to the 3rd, you would do x to the 5 times 3, and you would get x to the 15th. And let me show you why that works. Remember, this power is telling me how many of these I have. So I have x to the 5th times x to the 5th times x to the 5th. And if we use our old addition rule, we have 5 plus 5 plus 5, and we showed you how that worked. I showed you how that worked on the previous page. So this would be x to the 15th. So notice we get the same thing. So what's happening here is when you raise an exponent to another power, you multiply those exponents. Okay, next we have our multiplication. So what if there's two bases raised to some exponent? Okay, so notice two things raised to some exponent. That means I need to raise both of those things to the exponent. Okay, so my example, if I have 2x squared y to the 5th all to the 3rd, that means I'm going to have 2 to the 3rd x squared to the 3rd, and remember I just learned I multiply those, and y to the 5th to the 3rd, again I multiply those. Now here's where it gets a little tricky. 2 is a number, so in my calculator I grab it and I need to do 2 to a power of 3 and figure out what that number is. Because it's a number and I can do 2 times 2 times 2 and get 8, I need to replace that with the number that it's equal to. Now x is not a number, so I can't put that in my calculator and figure it out, so I just leave it as a variable. And y, same thing, I just leave it as a variable. But if you have a number raised to a power, you actually need to get out your calculator and figure out what that is. Okay, and then what if we have division? A divided by b to the m. Well, same thing. That means I have a to the m divided by b to that same power. So let's try that similar example again, except this time I'm going to have 2x squared in the numerator and I'm going to have y to the 5th in the denominator. Raise that to the 3rd. Okay, so that means I need to take all of these to the 3rd. So 2 to the 3rd we just learned was 8. X squared to the 3rd we just learned was x to the 6th. And y to the 5th to the 3rd we just learned was y to the 15th. Okay, now you need to be careful though. This is all well and good when there is multiplication inside your parentheses. But what happens when there's addition inside your parentheses? Can I just go, okay, this is x to the 3rd and 4 to the 3rd? No. When it's addition or subtraction inside your parentheses, it must be FOILed. So you would have to multiply those together and multiply them together. You'd have 3 of these. So you would have x plus 4, x plus 4, and x plus 4. So you can either multiply all those together or use our Pascal's triangle that we learned. Okay, so don't use this shortcut when there's addition in between. That's something different. Okay. Last couple things, the easy parts. If you ever have anything at all raised to the first power, it is that same base. So if I have 9,243 b to the 4th all raised to the 1, that is 9,243 b to the 4th. So exactly the same thing as it was. And then the easiest one, my favorite, if I have anything to the 0 power, it is 1. So if we have negative 784 b to the 7th and we raise that to the 0 power, 1. So anything ever that you have in your examples raised to the 0 power, I'm just going to replace it with a 1. So let's try some examples now. So I have 3x squared y to the third. Okay, so that's using this property right here, that I have things being multiplied together raised to a power, so I need to raise them all to that power. So I'm going to have 3 to the third, x squared to the third. Now we learned, oh no, that was up here. We learned up here, if you have a variable and you have a power to a power, you need to multiply them. So it's going to be 2 times 3. And then y, well, it doesn't have a power, but there's a 1 there. If it doesn't have a power, 1 times 3. So my answer is going to be 3 to the third. So if you can do 3 times 3 times 3 in your head, do that. Otherwise, grab your calculator to get that 27. Then 2 times 3 is 6, and 1 times 3 is 3. So that's your final answer. And let's try another one. Okay, so 5x to the negative 2. Alright, now remember, negative exponents we have to take care of, right? But what if I have a negative exponent to something in parentheses? Well, when that happens, when you have a negative exponent, outside some parentheses, you need to flip what is inside the parentheses to the other side and make the power positive. So this whole thing from the parentheses moves to the other side of the fraction bar. So I need to flip and positive my power. So right now I have this as over 1, so I flip it 1 over 5x, and now it's to the second. If I had more stuff out here, I would need to make sure to move this whole 5x down to the other side. So now I need to square everything, so 1 squared divided by 5 squared times x squared. So 1 squared is just going to give me 1, 5 squared is 25, and x squared is, I just leave it as x squared. Okay, a few more. Negative 5, x squared, y to the negative third, divided by 2. Okay, so the first thing I'm going to look at is see if I have anything that I can't have going on, and I see I have a negative exponent. So since I have that negative exponent, I need to, just as in my last example, I need to move the thing with the negative exponent, not all of this, just the thing with the negative exponent. So y has the negative exponent. That whole thing is going to move to the other side of the fraction. So I'm going to have negative 5x squared divided by 2y, and now that I've moved it, the exponent changes signs. It's okay to have a negative 5 because it's not an exponent, and I can't multiply those. I can't multiply those. Can I simplify negative 5 over 2? I can't. So this actually is done. Okay, maybe this one will get more challenging. 2x squared y to the third divided by 6x to the fifth y. Okay, yeah, this is going to get more complicated. Okay, so let's get some colors going on, just because. So let's see what's going on here. Well, I notice that my numbers out here, 2 and 6, those are both even. So They are, remember, they're called coefficients if they are a number in front of letters, and they need to simplify if we can. I couldn't simplify 5 and 2 because they don't both divide by something, but these do. They both divide by 2. So if I divide 2 by 2, I have a 1. I don't have to put that 1. Divide 6 by 2, I have a 3. Okay, now let's look at what else is going on. Okay, well, I notice I have x's, numerator and denominator, right? So remember from our first page, if I have the same base being divided, I subtract them. And I'm going to subtract in an order that I want to subtract in an order that will give me a positive. So would 2 minus 5 give me a positive, or 5 minus 2? Well, 5 minus 2 is going to give me the positive. So since I'm starting my subtraction with the 1 in the denominator, that means my x is going to stay in the denominator. Basically, it's wherever the larger power was, that's where your variable stays. Then I do 5 minus 2, so I get x to the third. And then last but not least, I have some y's here. Y to the third and y to the first. Remember, I use the cheat code of wherever my larger variable, my larger power was, that's where it's going to stay. So I do 3 minus 1 and get y squared. So I can leave that as 1y squared divided by 3x squared, or I can change it to y squared divided by 3x cubed. I said squared, didn't I? So you can leave the 1 there as a coefficient, but you do not have to have it. Okay, now these next two I'm going to do next to each other and work my way down because they are kind of long problems. They have a lot of steps, and I want to be able to work down instead of sideways because I will run out of room. They're not going to be on a singular, there's not just 2 steps. Okay, so this next one, negative 2 x to the negative first, y squared x, those are all being multiplied by the way, x to the fourth, y to the negative second, all to the third. Okay, so the first thing I need to do is, since I have parentheses, I need to look inside these parentheses and simplify it. So what can I simplify in there? So the numerator I'm just going to leave this exact same because I don't want to mess with too many things at once, and right now the only thing I see I need to take care of is that negative exponent. But here I have a negative 2 and I don't have any other numbers, so I'm going to keep that. X's, I have x to the negative 1 and x to the fourth. So remember from this very first page, if I have the same bases, different exponents, I add the exponents. So I have an x and I've got negative 1 plus 4, so that gives me 3. My y's, I have 2 and negative 2, so that gives me 0. And that is all still being taken to the third. Okay, I don't know if you remember this or not, but y to the 0 was one of our special properties. Y to the 0, or anything to the 0, is 1. So I can kind of cross that off and replace it with a 1, and when I take 1 to the third, that's not going to change it. Okay, so now I need to take everything to the third power. So I have x and y to the negative third, and then I'm going to have negative 2 to the third. So get your calculator. Since this is a negative, make sure you put it in parentheses. So when I do negative 2 to the third, it gives me negative 8. And does that make sense? Negative 2 times negative 2 times negative 2. Yes, that's negative 8. And then I have x to the third. And when I have a power to a power, what do I need to do to those exponents? I need to multiply them. So that's going to be x to the ninth. And then this y became just 1, and 1 to the third is 1, so that's not going to change anything. Okay, so now I need to get rid of this negative exponent by moving it down. So I have x divided by negative 8 x to the 9th, y to the 3rd. Okay, is there anything else I can do? Yes, there's one last thing I can do, and that is simplify again with these x's. So remember, you subtract them when they're divided. This has an exponent of 1, so 9 minus 1 is 8, and then since I started with the 9, my x stays down here, so 8, and y to the 3rd. Okay, now those are all in the denominator, and this x is no longer in the numerator. Remember, this has an imaginary coefficient of 1, so if everything disappears from the numerator ever, you still have to leave a 1 there to hold its place. Okay? So you can leave it like this, or you can bring the negative out front and make it look like that, where the negative's out front. Or you can actually even move the negative to the numerator. I'm not going to be real picky, so if you want to just leave it like that, it's perfectly fine. But I want you to know that that negative can move around. Okay, so you can write it any one of those three ways. Alright, finally, last example. So if I've got x to the negative 2nd y divided by negative 3 x y to the 5th x to the 4th y to the negative 1st. And I have that all raised to the negative 2 power. Okay, so I think I want to start by simplifying some of this guck in here, because it's just getting really, it's just a lot of stuff going on. So in the numerator, can I simplify it all? No. They are different bases, so I cannot combine them. In the denominator, I have a negative 3. It doesn't have a buddy to multiply by, so I leave it. Now, my x's, I have x to the 1st and x to the 4th. Do you remember what we need to do to those exponents? I hope you remember that we add them. And then y's, I have y to the 5th and y to the negative 1st. And I hope you remember that we add those as well. Now, to take care of this negative, I need to flip the whole fraction. If I flip the fraction, make it negative 3 x to the 5th y to the 4th divided by x to the negative 2nd y, then that negative 2 becomes a positive 2. So instead of doing what we had and just like, where was that? Instead of only having one thing and over 1 to the negative 2 when we flipped it, okay, now we had stuff down here. So anytime you have a fraction raised to a negative exponent, flip the numerator and the denominator, and then that exponent will be positive. Okay, so now let's go ahead and simplify in here some more before we take stuff, because that's our order of operations, right? Order of operations is that we simplify inside the parentheses as much as possible before we take anything to a power. Okay, so negative 3, does it have another coefficient to simplify with? No. But my x's do. I have x to the 5th and x to the negative 2nd. So if I do out here x to the 5th, and since it's being divided, I would subtract negative 2. So that'd be x to the 5 plus 2, which would be x to the 7th. Sorry, I didn't use a better contrasting color. Okay, and then my y's, well, I have 4 minus 1, so that's going to be y to the 3rd. Oh, so look, I just took everything out of my denominator. So it's over 1, and do I really need that over 1? I don't. It's not needed. Now, you might be asking, why do I need it when it's in the numerator and not in the denominator? Well, the reason you do is because 1 divided by this crap is going to be some decimal possibly, like if you did 1 divided by 2, that's going to be 1/2, and it's going to be 0.5. But if you do 2 divided by 1, that doesn't change it. So anything divided by 1 is still that same thing itself, so we don't need it. So now I have negative 3x to the 7th, y to the 3rd, all squared. So see how that came down to just this, and now it looks very nice. And so if you are going to put this in your calculator when you do, because remember now you need to square everything, negative 3 squared, remember not to put it in your calculator as negative 3 squared, because that will give you negative 9, which is not correct because negative 3 times negative 3 is positive 9. So remember how you need to put that in your calculator is negative 3 in parentheses and square it so you get the positive 9. Make sure anytime you're dealing with negative numbers, taking them to a power, you put them in parentheses. And then we multiply our exponents because it's a power to a power. 9 x to the 14th and 9 to the 6th. Okay, go back on my website and find the 6-1 Properties of Exponents worksheets and get to work.